Hello, my name is Katrina Castro, and I'm an aquatic ecologist with Colorado Natural Heritage Program. The following presentation will cover the methods used to collect water quality data. You can follow along in Section 7.2 of the Field Protocol for lentic, riparian, and wetland systems. Water quality is a contingent method within the Field Protocol for riparian and wetland AIM systems because many riparian and wetland areas have intermittent or seasonal hydrology and lack standing water throughout much of the growing season. Project leads should decide if and when these measurements are collected based on monitoring objectives. If water quality measurements are taken, these measurements should be made before any other data are collected to minimize sediment disturbance and turbidity in the water column, which can impact water quality measurements. Collecting water samples early in the sampling day will also limit the impact of diurnal changes in water quality due to temperature fluctuations and metabolic activity of organisms in the water. There are two types of water quality methods described in the riparian and wetland AIM field protocol. The first method described is the in situ measurement of pH, specific conductance, and temperature. Second is the collection of a water sample or grab sample that will be sent for laboratory analysis of total nitrogen and total phosphorus, otherwise referred to as TNTP. Measurements of pH, specific conductance, and temperature can include measurements of both surface and groundwater, and can be taken from multiple locations within the monitoring plot, including from within the soil pit, within flowing channels, and in standing or sluggish surface water. A single sample of surface water should be collected from one location within the monitoring plot for future laboratory analysis of total nitrogen and total phosphorus. All water samples are collected from surface water. Water samples are never collected from within the soil pit. To collect water quality information, you will need a multi-parameter water quality probe, such as a YSI, calibration solution appropriate for the water quality probe for both pH and specific conductance, deionized or distilled water, two 250 milliliter plastic graduated cylinders, a meter stick, a 125 milliliter sample vial, nitrile gloves, packing tape, water quality labels printed on Write in the Rain paper, a long-handled dipper cup, which is optional, a dropper of sulfuric acid stored within an Nalgene containing baking soda, and safety glasses or sunglasses. When collecting in situ water quality data, we collect pH, conductivity, and temperature. pH is a measurement of hydrogen ions in a solution. The more hydrogen ions, the more acidic the solution, and the less hydrogen ions, the more basic the solution. Runoff from activities such as mining can result in lower pH values. Conductivity measures the capacity of water to conduct an electrical charge, which increases with the concentration of ions in a solution. Conductivity is commonly correlated with the degree of salinization. Activities such as irrigation runoff and return flows can increase conductivity levels. Water temperature can have a direct influence on the diversity and distribution of organisms within a body of water. Water temperature data should always be recorded on the Celsius scale. Before collecting any water quality measurements, it is important to ensure that the water quality probe has been successfully calibrated following manufacturer recommendations or within the last 7 days, whichever comes first. Crews should maintain a calibration log with their sensor to document when and how the water quality probe was calibrated. Additionally, if the YSI values are atypical, it is essential that crews recalibrate their machine. If there is explainable reasoning for the unexpected value, please include comments. Prior to collecting the first water quality measurement, record the ambient air temperature in Celsius based on the reading from the probe. Select at least one and up to 4 locations within the monitoring plot that represent surface or groundwater conditions. At each location, record a GPS waypoint and measure and record water depth. For surface water, note whether the water is standing or flowing, clear or turbid, and open or shady by vegetation or other overhanging features at the time of sampling. The component of the YSI sonde circled in red is referred to as the probe. Multiple sensors exist on different locations of the probe. The water depth at each measurement location must be deep enough to submerge the entire probe. If water is not deep enough to cover the entire probe, water quality measurements should not be taken at that location. Though there is not an established minimum water depth, be sure that the probe is fully submerged and is not resting in sediment, as this can affect the instrument's readings. If it is not possible to submerge the probe without disturbing the sediment, a 250 milliliter graduated cylinder can be used to collect water, and the measurement can be taken by immediately submerging the probe in the cylinder. When collecting water quality measurements, be sure to allow enough time for readings to stabilize before recording them. This can sometimes take several minutes. In addition to in-situ water chemistry data, a water sample is collected from a single location within the monitoring plot to be analyzed for total nitrogen and total phosphorus. Nutrients, such as nitrogen and phosphorus, are essential for plant and animal growth. However, high concentrations of nitrogen and phosphorus can have detrimental effects on the environment. Soil erosion, agricultural runoff, and excessive manure can all contribute to high concentration of nutrients. The location of where a grab sample is collected will vary on a site-by-site basis. Water samples are not collected from the soil pit. A water sample needs to be collected in an area of open surface water that is deep enough to prevent disturbance of the bottom sediments during collection. Preference should be given to surface water areas that are at least 15 centimeters deep, close to plot center, within the middle of a water body, and away from any inlets and outlets. If surface water within the plot is shallow, only collect if you can obtain a sample without disturbing the sediment. When collecting a water sample, it is important to use clean gloves to avoid contaminating the sample. Approach the sample location carefully and avoid disturbing sediment. All crew members should avoid walking close or upstream of the sample location. Rinse the sample bottle and lid 5 times with water from the sample location. If using a long-handled dipper, rinse the dipper cup 5 times before collecting the sample. If the water is flowing, samples can be collected carefully by hand. Always be careful not to disturb bottom sediments while rinsing the sample bottle and dipper cup. Carefully label the sample using a water quality label printed on Write in the Rain paper. Always be sure to use a pencil. Blank and duplicate samples should be collected at the first and every 10th site where water samples are collected. A blank sample consists of deionized water, which is treated as a sample collected in the field. Blank samples are used to identify errors or contamination in sample collection and analysis. Duplicate samples are water samples collected in the field by the exact same person following the exact same procedures as the original sample. Duplicate samples are used to inform the precision of sampling methods and laboratory analysis. If collecting blank and duplicate samples, be sure to collect the blank prior to collecting the original sample to avoid contamination. Additionally, all bottles should be clearly labeled prior to collection to avoid any confusion. To collect a blank sample, rinse a 125 milliliter sample vial with deionized or distilled water 5 times. Then, fill the bottle halfway with deionized or distilled water to allow headspace for freezing. When collecting a duplicate sample, be sure to collect it the exact same way as the original sample. If using the long-handled dipper, Fill each bottle part way with each dip of the dipper, rather than filling one bottle first and then refilling the dipper. Stabilize all samples except blank samples with concentrated sulfuric acid. Always store the sulfuric acid dropper in a Nalgene storage bottle containing baking soda when not in use. Ensuring that you are wearing proper PPE, including protective eyewear and nitrile gloves, carefully remove the dropper bottle cap, keeping clear of face. Invert and add 3 drops of sulfuric acid to the water quality sample. Seal the water sample and shake vigorously for 5 seconds. Always be sure to exercise extreme caution whenever using sulfuric acid. Nitrile gloves and eye protection must be worn at all times when working with sulfuric acid. If any sulfuric acid comes in contact with the skin, be sure to rinse with a mild soapy solution or rinse continuously with water if soap is not available. Be sure to neutralize any spills on the ground or other surfaces with generous amounts of baking soda. Be sure to freeze samples upon returning from the field. All samples will be sent for laboratory analysis for total nitrogen and total phosphorus at the end of the field season. There are several measures you can take to ensure quality data collection. These steps are also listed in the protocol at the end of section 7.2. It is recommended to reference these steps during and after a sample event. This concludes the methods for water quality and water sample collection. Thank you for listening.